The reality is this has become a clear economic choice. How do we now make these assets, perform for 20 or 30 years in the same fashion that we would expect a traditional generator?
The Solar Podcast is brought to you by Continental Energy Solutions. I'm your host, Tim Montague. Today on the Solar Podcast, solar project reliability and performance. My guest today is Brad Micallef, the president of Solar Ops. Welcome to the Solar Podcast, Brad.
Hi, Tim. Thanks very much for having me today.
It's great to have you on the show, and I'm really excited to dive into some very relevant topics for solar project owners, solar developers, and plenty of info here for solar installers as well. So let's get into it. You've been in the solar industry a long time, so tell us a little bit about how you got interested in renewables and how you grew your companies.
Sure. So Tim, this is actually my 12th year in utility scale solar, and I actually started out with the module manufacturer here in the United States, where I spent about 6 years. And from the module manufacturing side, moved into both EPC and then O&M, or operations and maintenance, and also transitioned into asset management with a private equity firm, and ultimately found myself back in the O&M space here for the past 5 years. We created Solar Ops as both a service entity to perform O&M service contracts on utility scale projects here in the Southeast in North Carolina. But we also have a product line which is intended to help developers both operate and maintain and commission projects more quickly, more efficiently, and of course to improve reliability to maximize energy yield.
Excellent. And I want to talk a little bit about some of the technology trends as well that we see coming in. In the pre-show, you mentioned bifacial modules. Of course, we see the mass adoption of single axis trackers as well, and larger voltage string inverters. Now we see 1500 volt inverters coming into the market. Tell us a little bit about how you've seen the solar market change in the last 5 years.
Certainly. So from the utility scale perspective, which of course can be mammoth projects, 500 megawatts, and now we have some gigawatt size projects, central inverters really have driven the market in North America. But both in Europe and then also in the residential market in North America, of course, string inverters have had very heavy adoption. And over the last several years, we really see a trend where string inverters with higher voltages, 1,000 and now 1,500 volt, have started to, not only take over the C&I space, but also appear in surprisingly large utility scale projects. I've seen projects recently as high as 50 or even 80 megawatts. Likewise, the string inverters themselves have become larger in capacity. And, much how we think of IT, where at one point you had a very large mainframe, and everybody had a node. Now, of course, everybody had desktop computers. And if you look at all the servers in the cloud, what you really have is, a mainframe in the cloud, but it's made up of a lot of really small servers. And from an operations and maintenance standpoint, originally where I think we thought of string inverters as being maybe a nuisance or a low reliability, unsophisticated device, that's not the case at all. We see string inverters now that come with as much or more intelligence sometimes as a central inverter. And as these are being deployed by developers in larger scale, we're actually seeing the benefits of using string inverters to increase reliability. A single failure of one string inverter, it may not actually create a large outage, to a farm, and is much easier to service and replace than a large central inverter. So we absolutely see the trend of string inverters creeping into larger and larger utility scale projects. And we expect that to continue.
Yeah, I love that analogy. The decentralization of computing. We have a smartphone in our pocket. We have a laptop in our briefcase, and then we're leveraging the cloud, so to speak. And a string inverter can be carried by two men. So it just makes deploying replacements so much easier. or just the installation. You don't need a crane to move that equipment around your solar field.
Well, and I think there's some future proofing aspects to it as well. Where we see central inverters, they're pad mounted below a transformer, and that central inverter is very specifically electrically tied both with the AC standards of the transformer and the voltage, specifications, but also on the DC side as far as how the solar array was actually designed. And so you really end up with a very bespoke piece of equipment that, if you look out 5-10 years, may be very difficult to maintain or replace if you had to. String inverters, while they have the same AC and DC, standards and things, there are much greater number of options on the market where if you have a problem with a supplier or a warranty issue, you have the opportunity to essentially rip and replace an existing string inverter with an equivalent or similar string inverter on the market much more easily. And so, when we think of projects that are contracted for 20, 25, 30 years of expected life and beyond, we really see the string inverter as being a more universal replacement option than trying to maintain a central inverter for that same period of time.
Yep, I agree. And future proofing is so important. These are facilities that are going to be there for 25, 30 years. And so if you can just swap out a card, for example, and give your system an update and an efficiency upgrade. You see this with, EVs and Tesla with their over-the-air upgrades. They can improve the range of your EV with a software update. And if you can do that, it costs nothing. And so I don't know, do you see over-the-air software updates happening in the inverter space?
Well, certainly I think the potential is there. The inverter is in fact a computer, right? And a piece of power electronics device, and it relies on firmware, just like your Tesla cars or even your smartphones. For security reasons, obviously, when we think of solar plants penetrating the grid at both the distribution and transmission level, these in fact do take on the form of critical assets. And so there definitely is an IT security aspect to this. I don't think that we want settings and firmware changing, but most developers, in fact, have very strong security policies in place, even if they're not critical assets that would fall under NABCEP compliance. And good enterprise IT practices. That said, though, when there are updates available that potentially can improve performance or maybe reduce parasitic load for like cooling fans and things like that in a very controlled manner, again, through good operations and maintenance and asset management practices, those software updates absolutely can be applied. And, a project that was built even a year ago or 5 years ago, in fact, can become better, just like you said. And so that's the really exciting part about this is these are not just static aging assets. These are in fact generators that can improve with time. And it's a really exciting aspect, not just solar, but storage as well.
You're in the North Carolina market, which is, it's certainly a top 10, maybe a top 5 market even. Give us the latest. What is going on in the North Carolina market?
Sure. So early on, North Carolina was the number 2 developer in the United States due to some really favorable programs and policies here in the Carolinas. As those programs, though, allowed really a very rapid deployment of solar, I think that our not only our municipal and co-op utilities, but Duke Energy here as well, has really had to revisit some of their policies in order to how to handle what is an inevitable transition to a much greater reliance on renewables and eventually storage as well. We see some very exciting regulatory development here in the state, and policy changes as well. And, we are working hand in hand with the utility in order to help with that transition and, bring assets online that are, again, more like what they would expect from a traditional spinning generator, black start capabilities, fully integrated storage for frequency regulation and voltage sag response. So these are not passive solar assets. These are really truly generators that could operate 24/7.
And so we've touched on some of the trends in the inverter space, right? We see more and more string inverters coming in to the utility space. What about trackers and modules? Do you have an opinion about that?
I do. So the the module, I think, is where everyone thinks of a lot of the research and development innovation. And when I started over a decade ago, we were so excited to have a module that was even 10% efficient, a thin film company. And when I left the company, we were on the verge of being 16 to 17% efficient, and that took millions of dollars worth of research and development and manufacturing. As that translates into module sizes and wattages, though, we're now seeing 400-watt modules, which is just an incredible amount of energy density, really enabling that commercial industrial space, carport projects, even residential, where you're just able to get a lot more energy into a small space. Now, that helps on the utility side as well when we think of really large scale projects, because it's less racking, less wire, less land usage, less balance of system, basically. And when you couple that now with tracker systems, where the reliability of tracker systems, independent row or mechanically ganged row tracking, the reliability there, and wind stow capabilities has just really come a tremendous way, in the past 5 or 6 years with continued investment. And that also now helps energy yield in those peak hours of the day, what we call the shoulders, either in the early morning or in the late afternoon. Couple that, again, with module innovations like bifacial modules, where you can take advantage of that reflected irradiance that not only passes through and around the module, but now bounces off the other rows, bounces off the ground. You're just really seeing the optimization and maximization of what solar can truly do. And honestly, Tim, I think we're really still pretty early in the curve here of innovation. For as exciting as the first 10 years for me has been, I really look forward to what's coming in the next decade with storage.
Yep. It's going to be an exciting ride for the next, I say 50 years actually, but I won't be around for all of that, unfortunately. And, of course, now we're going to get some new leadership in Washington. There are some estimates out there that, we might be installing 800 gigawatts of solar by 2035. And so we are going to see a steep acceleration, not only in the US, but globally. Frankly, one of my concerns is, can manufacturers keep up with the pace of growth? Because China is also staged to really step on the gas. And that's my only concern. Will we have enough product? Because we're going to be installing it as fast as we possibly can. Here in the Midwest, we've seen trackers just completely sweep the field. 90+% of projects are using single axis trackers, and you get a 10 to 15% bump in performance that way, which makes sense. The only question is how reliable that equipment is going to be and how much maintenance it's going to require. So it's, TBD. Of course, Nextracker and Array Technologies are kind of tried and true, and I think have built very stellar brands. And now there's a growing cadre of other manufacturers coming into this space. I'm publishing an interview with Trina Solar. They have their own tracker product on the market now. They bought an established manufacturer. We see Solar Flex Rack going head to head really with certainly Array Technologies, and Array is moving into larger and larger projects. So they're giving Nextracker a run for their money and having gone public now this year. So a lot of activity.
Certainly.
What,
So,
what,
I'm sorry, go ahead, Tim.
When you think about long-term reliability of, megawatt scale solar projects, where do you see the opportunity for improvement and the challenges for reliability and performance?
Sure. So I think in large part, for any developer today, the really good news is while there are certainly different gradients of products out there, what you would consider, absolute top end products versus kind of mid and low range products. The great news is that the industry has come along far enough on quality control, of module supply, standards from IEEE, governing how inverters should operate, and of course initiatives in California like Rule 21, in order to ensure a basic set of operating guidelines for inverters. Even a poor choice of module inverters or trackers today is really a better choice than you might have had even 5 or 6 years ago. And so, that really opens the field up, I think, for commercial competition. And, Tim, you segued a little bit into politics and the new administration. I think solar sometimes really gets cast in this light as a political hot potato. And, certainly things like, module tariffs and, what we see on the news, as far as supporting older forms of fossil fuel definitely, sit in the hearts and minds of, not just Americans, but, I came from the Midwest. I mean, I myself was a machinist for a while. And so I'm very, aware of those concerns of labor and manufacturing. But I think what we really have here is when you look at industries that were invested in traditional forms of fossil fuel, we're being contacted on a fairly regular basis, not by politicians, but by people who come from a very mature service industry in oil and gas and even coal, where they're saying we want to start investing in renewables because we see that's where the market's going. That's not a political statement, that's an economic statement. And so while I think politics will ebb and flow, we see an absolute transition in some of, not just the, supply companies, but the service companies looking at how do we get on that train to help make this transition possible. And while I certainly would like to think that it's for all of the reasons of, being green and supporting the environment, which of course we support, those are added benefits to coming to work in this industry every day. The reality is this has become a clear economic choice. It makes sense to invest in these things. And so that dovetails back into the reliability of all this equipment is how do we now make these assets, perform for 20 or 30 years in the same fashion that we would expect a traditional generator. And here again, when we talk about reliability and we talk about operations and maintenance, we're looking to eliminate possible points of failure. And you can't do that solely through equipment selection. A lot of it has to do with design, right? Choices that you make up front, just like when you build a house, right? Trying to make sure you have a strong foundation, if you will, is really important. And what we've focused on in our business for our products to help support solar is really twofold. One, we want to eliminate as many field connections that have to be made as possible. So again, this is really custom, high-skilled work that might be done in the field under very undesirable weather conditions and things like that. And we want to try to modularize that as much as possible. And we have a product called the Clear Sky Interconnection, for instance, which takes your protective relaying and your utility tie and your metering, which is so critical for performance analysis and of course asset management for billing. And we put that in a piece of modularized pad mount equipment that simplifies the entire interconnection process for both solar and storage projects. The other vein that we've taken is about improved monitoring. So when we talk about the increase of string inverters or the increase of trackers on site, all those things really only are producing money and generating electricity for the asset owner and for the energy off taker when they're operating properly. And it's really important that you have a monitoring and a SCADA system that allows you to see into the plant in order to understand where there are problems so that you can respond to it very efficiently. So products that enable modularization for higher reliability, less field connections that have to be made, failure points, and then secondly, improved monitoring systems to allow for a deeper dive of what's actually running, where problems are, so that you can really efficiently respond to problems when they happen.
Yeah, I couldn't agree more. Reducing the number of connections made in the field is a very good thing. We're big fans of pre-construction here at Continental. We try to do 15% of our construction in controlled conditions. But it's a nice segue. Let's dive into your product suite. I'm going to share my screen here, and here's the PV Clear Sky Interconnection. Tell us about this product.
Sure. So this basically replaces 3 of the 4 most common overhead poles that you would have on a site. So when you interconnect with the utility, when that 3-phase system comes in, they start out with a riser pole, which just transitions over, and you might have some type of a disconnection device there, like a GoApp. That remains. But then where you would normally go to a recloser or what we call a protective relay, this is what basically intelligently monitors the grid conditions and also the output from the solar facility, and has the ability to intelligently, very rapidly disconnect you from the grid if there's a fault. You also then have revenue grade metering built into this. And then finally, in this version of our product, we actually also include fused cutouts, which is another form of protection for your 3-phase electrical system. And we provide these in a manner that supports IEEE testing requirements under 1547 for both 3-phase and also single-phase drop testing. So something you would normally have to do in a bucket truck, with very specialized, linemen and things like that, you now can do from the ground. And so we feel this is a much safer product. It is a long-term, less expensive product to both install, maintain, service, and operate. And it speeds up your commissioning process as well.
So when you think of this product juxtaposed with the old solution, in terms of time and materials, what is the delta?
So we actually brought this product to market to be competitive, both on a time and material basis. Just speaking of general cost, when you look at the cost of your interconnection of materials plus typical installation, we are on par with that. So this is not you don't have to take on added cost with this. From an installation perspective, this product can actually be moved to one of your transformer and inverter skid pads. And so this does not actually require as much land as you would normally use for poles. So that's more space for solar modules or access roads that you might need, and gives developers a lot of flexibility where they don't have to find as large of a right-of-way area. And then the actual installation here, most of these Clear Sky interconnections can be set without a crane. They're less than 5,000 pounds, so they can use equipment that they would normally have on site for moving racking around like a lull. And they can be terminated in half a day. So the electrical connections are, very simple in this case. Again, no bucket trucks or overhead line work needs to be done. And as you know, especially in late fourth quarter, rain typically becomes a problem for a lot of construction projects. These are small enough that a tent can be posted above them, and you can continue to terminate and work on this equipment safely, even through the rain. So it's a huge advantage even for just tight construction timelines.
Fascinating. Yeah, I can't I can't wait to lay eyes on this in the field. Is there anything else you want to say about the Clear Sky? I want to talk about your other products as well, but
Certainly.
seems like a really good step in the right direction.
Well, thanks. Well, it's really been received by the market very positively here in 2020. We brought it to market late last year, and literally they're flying off the shelf, if you will. We were, from a manufacturing standpoint, we were booked for the year. We're making several improvements to this product in 2021 that many of our customers are already very excited about. But we've had the good fortune to deploy these not only in the Southeast, but also in Colorado, Indiana, through a portfolio up in Michigan. And we have some planned here for the Northeast as well in first quarter. So these are really, taking off. I guess what I did want to say, though, is while we originally set this out as a distribution level interconnection up to 35 kV, we're seeing these are being adopted now by larger substation transmission level projects as well. So where you would normally have your substation and you break off into 20 or 30 megawatt blocks of solar energy, this is now providing metering and basically block level protection for projects like that as well. So we're seeing this product start to penetrate into even some of these large transmission level connected projects as well. So it's truly become a fairly universal building block. Up to 30 megawatts can be supported by one of these units.
So in a 30 megawatt project, though, there would be multiples of this Clear Sky box, so to speak, right?
Well, actually, at 35 kV, we can actually support 30 megawatts under a single box. And so, like, if you were building say 120 megawatt project, you might have 4 30 megawatt blocks, and we can deploy 4 Clear Skies on site. And it simplifies the substation build and deployment, and then it provides a lot of commissioning flexibility and, again, operations visibility into, metering, protection, and then, of course, we'll talk about SCADA here in a second, but all of these units come with SCADA built in to be able to do data aggregation, weather station, and inverter communication as well.
Excellent. And, here in Illinois, we have a 3 megawatt DC market, community solar market. In a 3 megawatt DC, 2 megawatt AC project, does the Clear Sky make sense?
It certainly could. So, a lot of these community solar projects are not out in very rural locations. They tend to be a little bit more, urban, where you have buildings, schools, hospitals, universities. And a lot of times you don't want a lot of that overhead, pole infrastructure. And so, and again, from a land right-of-way standpoint, you want to be able to deploy your community solar, on a smaller, piece of land and really maximize where you can deploy, either trackers or fixed tilt and modules. And so there are Clear Skies, that support lower voltage classes, including like your common 1247 or 2286 interconnections. And they are smaller than most of your step-up transformers, and they park really nicely up to where your inverter and your transformer is. And so they work great for community solar. Because it removes a lot of that, where does the interconnection go, and are those poles going to shade the modules? So from a developer, you really just have a lot more flexibility in design by being able to put the interconnection really anywhere you need to.
Got it. So let's talk about the other products. The EMTR station, is that something that is included in the Clear Sky?
Right. So EMTR is just our shorthand for meter. And we have a number of SCADA products that are cabinetized like this. And they're really meant to be retrofits for older sites or maybe smaller sites where an interconnection is being brought in overhead. So the energy meter station and the transformer station are all things to really enable a customer to kind of have Lego bricks to build up their SCADA system with. But the product that I'd really like to try to steer you here to, if you wouldn't mind, is our SCADA product called myPV IQ. And this is something that we built in. There you go. This product is designed first and foremost for security. This actually runs at the site, and it can work on a very small project like a CNI project, but also all the way up to a large scale 100 megawatt transmission connected project as well. We have some different versions of this, but this runs locally at the site, collecting your data and storing it securely at the site. We do have a cloud platform for this where you can aggregate a large portfolio of systems together from an asset management and O&M standpoint. But this is designed to really be a hybrid of what we would typically think of as monitoring, which is very easy to use, and SCADA, which traditionally is harder and expensive, but we bring what we feel is the best of a monitoring package from the ease of use standpoint, with some SCADA features, things to be able to control that recloser, open, close, and trip and reset, remotely. The ability to monitor at very high resolution data, real time for monitoring values when you have technicians in the field and you're trying to support them, historizing data at a 1 minute interval, monitoring alarms in real time. And so we've tried to bring what we feel like the best of the monitoring capabilities with ease of use, but also some of the really powerful capabilities of SCADA that allow you to really operate, a farm in a very efficient manner. And so, but we can support both string inverters and trackers, things that a lot of monitoring systems really struggle with very easily. The other thing that myPV can support is storage. So especially in both Massachusetts, where you have the SMART program, or New York, where you have the VETR program, you have scheduling requirements. You have the requirement to be able to balance your solar and your battery output so that you're still operating within your PPA or your interconnection limits. And myPV comes out of the box with features that allow, for that support. And so it's truly a platform that's built to help enable solar, but also to enable solar plus storage projects.
Cool. So you have a couple other categories here on your product landing page: generation system solutions and solar performance solutions. Do you want to talk about those?
Sure. So as solar becomes, let's actually go. We have a product called our El Jefe motor operator, and this is kind of an example, I think, of some innovation where it's our, there we go. This is our transformer switching device. And so as we see solar and now storage penetrate into different markets, different utilities really have challenges with how their grid was built out. And as you're adding all of these step-up transformers into fairly rural areas that were not designed, to handle large variations in voltage sag, or to have a generator at the tail end of a low voltage, distribution feeder. But when you start adding, these solar projects and these step-up transformers, you start running into problems with what's called inrush current when these transformers turn on. And you start having to do really creative things. And so this is an example where in our territory, where you might add a 5 or 10 megawatt project that has multiple step-up transformers, after a storm, when all of those transformers would turn on all at once, they would actually create a power quality issue on the grid. And so the utility, set out to try to fix that. And they basically said, is there a way to make the transformers where they turn on one at a time? And there's a lot of different ways to solve this, but we were looking for a solution that could be both a retrofit and also have a maybe some ancillary benefits down the road too. So this motor operator product, it actually allows for the time delayed switching of transformers to reduce that inrush current. The ancillary service that we found from this is it's a great transformer protection device. So step-up transformers are typically oil filled. And if the oil leaks out of a transformer to a certain level, it can become overheated. And when it does overheat, of course, I'm sure you've seen on the news, when a transformer catches fire in a substation, it is just a hot, glowing, disastrous problem. And, a lot of people who, developers, in particular, transformers are not only expensive, they're very long lead time items. It could take 16, 18 weeks to get a transformer. You've got to crane it in. It's just really, it's a huge hit to your financial pro forma, not to mention environmentally, an oil fire is terrible. So these devices can actually be put into transformers, and we can detect a low oil condition or an overpressure condition, for instance, and we can actually intelligently switch the transformer off, preventing a failure. And all of these devices can talk with third-party monitoring systems, as well as, of course, our own monitoring system, myPV, in order to let people know that there's a problem, and then actually proactively take action to prevent a catastrophe. And so this is just an example of some, other innovative products that we have that are a little bit out of the normal. You're not always going to need those. But again, as we see more deployment of both solar and storage, we see more opportunities and challenges for the industry to innovate and, bring forward solutions to problems that may come up, even if they're regional.
Well, I'm drinking from a fire hose here. I want to circle back to the big picture, Brad, and talk about LCOE, or long-term cost of energy, which is really the goal of any energy project, right? And so as we see the solar industry maturing, technology is becoming more cost effective, installation techniques are becoming more cost effective, and then it's this hybridization, right, and innovation that we see here with your product suite. But if you could put a bug in the ear of developers around LCOE, what would you tell them?
Certainly. So again, in the decade that I've been involved in solar, the focus in the industry has been very clear. The deployment of capital for the purpose of building projects. And I think that focus has been very good to help really kickstart the industry. But I'm very surprised at the lack of maybe focus that I see even today on long-term operations and maintenance for these projects. And I think that's largely because, much like if I were to buy a computer or a TV for Best Buy, and then they always ask me at the cash register, hey, do you want to buy the extended warranty with that? And of course, I always say no, because I don't see the value in it. And so I think that is a similar attitude in solar, where we really need to look at, if in fact these are 20, 30-year generating assets, what decisions can we make up front? Do we really understand and know enough to build a facility that can be maintained in a more cost-efficient manner? Are there lessons learned from projects, that have already been out there, for 5 or 10 years, whether it be in North America, or some longer in Europe, to build more resilient systems? And I think the answer is absolutely yes. I have not seen the same amount of investment in software or large third-party aggregation of customer service platforms, for instance, in the O&M space, as I've seen, for instance, in the development of software for residential sales software. And so I think that there needs to be a focus, a shift in the focus of saying, while we're deploying these, what can we do to really think about the long term? And I think for people listening to this podcast, if they could just take away one message maybe today, it would be, ask the people who have to maintain these long term about your project designs, early on. When you get to that 30% or 50% electrical design stage, where there's still a little bit of fluidity, in decisions about where disconnects go, and maybe what type of wire sizes, or fuse selections or things like that are being made. Really, really simple changes to some of your strategy that maybe they're seen as being cost optimized a little bit, but they create a pariah from a maintenance standpoint long term, something really special and really hard to source, that can really lead to long-term outages later. So take a moment and simply ask the people that have to maintain it long term, before you really commit to a final design. And then, of course, there's that old adage of tripping over dollar to save a penny. We see a lot of really intelligent, smart people at all levels, management, engineering, construction, et cetera, look at something from their perspective and maybe try to optimize it from, their point of view, not realizing the ripple effect that decision might have long term. And so, there too, I think having a really healthy collaboration with the folks that have to maintain and operate long term, when some of those design and construction decisions are being made, they really have a tremendous impact long term.
Yeah, I think that's where vertical integration does have its advantages. Many developers are flipping their projects at NTP or COD and then moving on. Now I see a trend that many developers are becoming long-term asset owners as well. And of course, then they have a stake in the long-term performance of the project, and they're going to think longer term. So there is that. There is a race to the bottom many times, right? We're a CNI and small utility scale installer and EPC, and the competition is brutal, and it is oftentimes a race to the bottom. people want a low cost solution, and that means lower quality equipment, lower quality construction. And then I also uh, see that there's just habits. Engineering teams develop routines in their designs that are tried and true. They know work, they know will pass muster with the utilities or with the AHJs, and they just keep driving that same nail home, when in fact, the industry is completely in flux. As we've seen here with your suite of products, I think you are demonstrating that there is plenty of room for improvement with these utility scale solutions, and they're just in a little bit of a bunker and don't take the time or effort to pop their head out and talk to people like yourselves. I mean, I can't tell you how many times we see great opportunities for optimization of designs, but they're already at the 90% stage, right? And they just they don't want to deal with that. It would mean a slowdown. It would mean, you know, a delay, and nobody wants that. So you're right. Go there early, go there often, and let's embrace innovation in the design and in the technology as we see this industry continue to mature. Brad, in the last couple of minutes that we have, first of all, how can our listeners reach you first and foremost?
Sure. So we actually have two websites. Our main company website, which touts our O&M services, is solar-ops.com. So solarops.com. And you can certainly contact us there if you're interested in O&M services or even just operations services. We also do offer consulting for both project developers and other O&M providers. So if you are just simply looking to have a chat with us about the trends we see and maybe how you potentially could do things differently, whether you're trying to use our products or not, visit us at solarops.com. And then for folks who are interested in modularized interconnections, maybe you have some project challenges that require things like inrush current mitigation, or of course are just looking for a refreshed look at your performance monitoring and SCADA, visit us at our product website, myPV.pro. That's myPV.pro. And we certainly hope to hear from many of you.
Wonderful. Well, I want to make a couple of quick announcements. We bring you these interviews twice a week, plus a clean power hour. So 3 videos a week. You can find all of our content at cesnrg.com/videos. Here you see the episode I referenced with Trina Solar and Ryan Simpson. We're talking about trends in PV modules. 550 watt and 600 watt modules are coming in 2021 to North America. So get ready. I was specifying 380s just 12 months ago, and now we're going to be in the 500s. And then PV inverter and storage scorecard with Michael Mills Price of PVEL. So many wonderful deep dives into technology and trends. Here we have floating solar with Chris Bartle at Seal and Tear, solar PPAs with Micah Sussman. So check out our content at cesnrg.com/videos. Please subscribe to our channel on YouTube. Please give us a thumbs up and please share and comment. We love to hear from our listeners and viewers. That's how we bring you the content that is so relevant to you, solar developers, solar installers, solar professionals, or aspiring professionals. With that, I want to thank Brad Micallef for coming on the show. Thank you so much, Brad. I look forward to having you back on the show. It's so early days for the innovations that you're making. So I want to continue the conversation about long-term operations and maintenance, solar project performance. Thank you so much, Brad.